Chesapeake Bay is a popular vacation site for many people. It's the perfect place for weddings, vacation, and everyday life. The Bay watershed is located in 6 different states, and it consists of over 100,000 creeks and rivers and streams, called tributaries. There are over 3,600 organisms that rely on the Chesapeake Bay to live. We conducted an experiment to show us what happens to a plant in the Chesapeake Bay when it is exposed to these nutrients. We created a realistic environment to give the plants a normal habitat. This experiment allows us to see what effect fertilizer has on the change in mass and percent change of Elodea.
In this experiment, we were asking the question, how does fertilizer affect plants, like Elodea in the Chesapeake Bay? We hypothesized that the greater the concentration of fertilizer, the larger its change in mass will be.
The independent variable of this experiment is the amount of fertilizer, and the dependent variable is the change in mass. Our baseline measurement is the mass of the Elodea at the beginning of the experiment, and the constants are the type of plant, the amount and type of water, the amount of sunlight, and the size of the experiment containers.
During the first experiment, there are 24 test tubes representing 3 trials for 8 treatments. Within the first week, it was obvious that something wasn't right, so we changed a few constants to improve the accuracy of this experiment.
We changed the size of the growing container to a soda bottle so that we could have more Elodea in each container. We made this decision because we found out that Elodea generally grows better when it is with other plants. Everything that we changed from our first to second experiment was so that the growing environment was more similar to how Elodea would grow in the Chesapeake Bay.
We measured the Elodea every 7 days to see how the mass had changed.
Our baseline measurement was the mass of 3 healthy Elodea sprigs that measured to be 11 centimeters, and most of them weighed around 1.6 grams. We measured the mass of the Elodea in our experiment by taking them out of the container and drying them slightly. We then weighed both of the trials together as one treatment measurement.
Treatment 2 was slightly different because the Elodea had created roots and attached to the soil. Consequently, there was dirt attached to the Elodea. We did not remove the dirt, but included it in the measurement, causing it to be much heavier than the other treatments.
Overall, the Elodea sprigs gained mass when fertilizer was added to the water. The percent graph shows clearly that most of the Elodea reacted well to the fertilizer. However, when there was no fertilizer, the Elodea stayed the same, and when there was a lot of fertilizer, the Elodea lost weight and became less healthy.
We learned that fertilizer benefits Elodea growth if it is the right amount. It cannot have too little or too much, but the right amount will grow and develop. The amount of fertilizer makes the Elodea grow or shrink. When there is not enough, it does not grow, and when there is too much, it starts to die.
This lab worked well because we gave the Elodea more room to grow and we added sediment to the water, allowing the plant to grow roots into the soil. Having more than one sprig in the container also had a positive result because they grew together well. The first and last treatment did not work very well because there was not the right amount of fertilizer to let the Elodea grow.
Some unknown factors in this experiment were the amount of sunlight because our containers were moved around in the greenhouse often. We do not know if sediment was the best way to make a realistic environment. We could have had better results with no sediment.
If we were going to redo this lab, we would add some factors to the container to make the habitat more realistic to what the bay is like. We would also measure the LED with more accuracy by possibly measuring the length and weight or counting the leaves as well to see what the overall health is. The next step of this experiment would be to see how other organisms in the bay react to the healthy or unhealthy Eladia and how this affects the overall bay health.
Our science class went on a field trip that directly relates to this experiment because we were measuring the health of the bay on this trip and we saw how other organisms are reacting to the extra nutrients. This showed us that it is not just the LOD that is affected by the fertilizer.
There's a problem in the bay, and that is that fertilizer is getting into the water, causing plants to overgrow, and all of this can lead to eutrophication. Most fertilizer has phosphorus and nitrogen in it, and most farmers do not realize that they are putting way too much on their fields. When it rains, the fertilizer runs off the land and flows into the bay. Even all the way in Pennsylvania, the fertilizer will get to the Chesapeake. Everybody makes an impact, so we need everybody to pitch in to make an effort to fix this problem.
The solution to this problem is simple. We need to use less fertilizer on the farms and throughout the watershed. This is difficult, however, because farmers need nutrients to make their plants grow. Some other solutions are using fertilizer solutions that do not include nitrogen or phosphorus because those are nutrients that affect the bay the most. Another solution is to stop the nutrients from reaching the bay by putting something in your yard to stop runoff. One example is a rain garden. The rain garden collects the water and filters it back through the area in a big cycle. This lets the water and nutrients get reused so they do not reach the bay.